Okay. So this is the first part of the second derivative here. And so the problem was, how do we find the other part? So adding everything else together, the next part we have to figure out is ddr of dz dy. So that was kind of the issue we had up here. So this is actually another chain rule property. So this is just going to be, according to our chain rule equation. That. Okay. Now, if we simplify this portion here, we actually get this. So we get a mixture right here. Okay. So now the final derivative, or the second final derivative, would be this together, and the mixture of it. So notice we have to put some stuff in respectively, right? So right here, we have to put all of this into there, right? And just distribute. And eventually, finally, we get our second derivative. So if you're wondering why we don't do second derivatives when it comes to partial functions and stuff like that, is because it gets very complicated very quickly. And you guys can imagine the third derivative is even worse. So just a quick little example illustrating, how second derivatives can be painful. I'll never ask you to actually calculate the second derivative, but it's something you could see. It gets really, really lengthy, and in most cases, finding second derivatives can be, in general, pretty bad. Now, to finish up the section, we want to go over implicit differentiation. So how does this implicit when it comes to the chain rule? Now, it's actually much easier than you may think. Implicit differentiation. So remember, when it comes to implicit differentiation, you want to solve for y prime, right? Given example. So let's say if we're given this, for instance, it's easy to solve for y, but what if it's, a little bit more complicated? So if we take the derivative of this, remember it's chain rule, right? Implicit differentiation. So it's 3y, let's say this, for instance. And we want to solve for y prime, right? That's implicit differentiation. Okay. So this is kind of what we're doing here, but it's actually much easier than you may think. Because given a vector f that's equal to 0, then the derivative of y, or dy dx, is given to be this, which is actually much nicer to deal with, because now all we have to do is find the partial derivatives with respect to x and y and just put them into a fraction format. And that's guaranteed to be our implicit differential, or solving for dy dx. So no more solving for, manipulating and solving with y prime. We simply just use a nice little equation. So for example, so we want to find y prime. So first we do f of x, and we'll do f y. So to respect to f, well, actually first we got to bring this all to 0. There you go. So we get satisfied with the exact one. Okay, so now we take the derivative with respect to x itself. And then respect to y. So that goes away. Oh, no. This is squared on this one. Okay. That goes here. This stays the same. Sorry, I didn't see that there. Okay, so now dy dx is equal to that divided by that with a negative in front. Yep. And that's how we take implicit differentiation. Way easier than may have think to do so, right? Okay, so let's try a couple more examples to finish up this section. Now, this is an interesting topic here because if we're given an equation with 3 variables, so now the implicit differentiation is actually 2 put together. So it's 2 answers put together. So if we have f with respect to x, y, and z, our derivative is actually 2 types. We have to find both of them itself. So we're going to find each one with respect to x and respect to y. Okay. So whenever you have 3 variables, then it jumps automatically to basically the chain rule. You have 2 actual answers respectively of each. Okay. So first off, we have to set this equal to 0. So we have to bring all this to the other side. And then next up, we get to find partial derivatives with respect to x, y, and z. So taking derivative with respect to x, that goes away. It should give me that. Okay, then we do the same thing for y now. So that goes away. That goes away. And the 20 goes away. And then finally, with respect to z. So goes away, goes away. And I think that's it. So now, dz dx is going to be f over z. So that divided by that. There we go. And then dz dy, y over that. There we go. Finish up this section pretty short. Any questions?